Hello, so today we are going to do this problem, which is a part of Leetcode December daily challenge. So what the problem says is we get a linked list, we get the head, and we want to return the middle node of the linked list. If there are only two nodes, then the second middle node, basically this says that if it's even, then we want the second middle node, right? So this one, 3, 4, 5, it's add. So add, it's easy, it's just the middle one. And then here we have 3, 4, 5, 6. Here we have even. So you can see here, it's not this one, it's this one, the second one. So these two are the middle, and this is the second one. So that's what the problem is asking. Now let's see how we can solve it. Okay, so let's see how we can solve it. So actually this is, there is a known trick to use, which is to have two pointers, a slow one and a fast one, right? And we move this by one each time, so each time we do slow dot next, but this one we move it by fast, 2 times fast dot next. And the hypothesis here is that once this reaches the end, this would be in the middle. And so we can just return it. And so with this hypothesis, let's see if it works. And all we need to do to see if it works is to test with an odd length one and an even length one, because those are the two where the problem says the middle node may be in different positions, right? So let's first start with the odd length. So let's say odd length. Let's pick the one in the example. So we have 1 to 2 to 3 to 4 to 5, right? Okay, so we'll pick slow. We'll pick slow and put it in the here. Both of them start here. Okay, so first slow moves here, and so we remove it from here. I'll just call slow S and fast F. And so here this would be S now, and fast would be here because we move it by 2, right? And then we move again, and so fast becomes here, and then slow becomes here. Now, one thing to clarify is our stopping condition here is either if fast is null, none in Python, or fast dot next is none. So either of those, because in both cases we can't move anymore, right? And so here we are done because fast dot next is none, right? Because the next of 5 is none, right? So we stop here, and slow is our middle, and that's exactly right. That's exactly what the problem shows us, right? So it works for add. Now let's see for an even length one. Let's pick maybe let's pick the example also in the problem. So we have 1, 2, 3, 4, 5, 6, right? Okay, so we have first the pointer at S and F here on the first node. Now we move S by 1, and we move F by 2, right? And then we move again, so F becomes here, and S becomes here, right? And then we clear this up. And then the last one we move F, and so F is none now, right? It's none. And then we move S by 1, right? So we move S, and now we are done, and the middle is actually 4, like the problem says, right? So we can see it should work for both cases, and you can generalize it because there is nothing special about those two examples. It should work for any linked list of the same even length or odd length, right? Yeah, so that's pretty much the idea. Now we just implement it and make sure it passes test cases. Okay, so let's make sure this passes test cases and run it. So what we said is we need to have slow and fast pointer, and both would need to point to head initially. And then we will keep going while we have these two, because otherwise we can't move anymore. And we advance slow just by once. We advance fast twice. And then at the end, our mid pointer should be slow, so we should just return it. Okay. So we run this, submit, and this passes. In terms of time, this is linear in the length of linked list, so O of n time. In terms of space, we are not really using any big extra space, so it's O of 1. So yeah, so it's O of n time and O of 1 space. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.